Chapter 10, Section 4 is all about Newton's third law. Chapter 10, Section 4. This is Newton's third law. And Newton's third law basically says that if one object oh, sorry.
That's a natural brain.
If one object exerts a force and remember that forces are measured in newtons, exerts a force on another object, then the second object exerts an equal force in the opposite direction. On the first object. Now, we can give an example of this. If we had a block of wood and we pushed that block of wood on a tabletop with a force of 5 newtons, and we had another block over here and it was stationary, 0 newtons, and this is at time 1. So we push it, and a little while later, that block connects with this block here. This block, and it doesn't move. This block here will exert a force of 5 newtons on the first block. So they're exerting an equal force on each other. So if one block is moving with a force of 5 newtons and it impacts another block, that second block is going to push back with an equal but opposite force. Jack. So in this example, the first block is going to hit the second block, and the second block is not going to move. There's another factor involved in this, and I'm going to get to that in just a minute, that explains why. Yeah. So it depends on mass. Good. So Newton's third law of motion, that objects exert equal and opposite forces on each other, involves something that we call action-reaction pairs. This is an action-reaction pair. Action-reaction pairs. Basically, there is a formula for something that we call momentum. Mathematical formula. Momentum can be calculated by multiplying the mass times the velocity. So Jackie, to answer your question, the mass will determine if the second block moves or it doesn't move. In this case, it was heavy enough to where it didn't move. That was just my example there. Let's go up here now and abbreviate the momentum equation. Momentum is equal to mass times velocity. Is there a circle formula for this if it has 3 variables?
Yeah.
Yeah. Who thinks they can figure out what the circle formula is? Annie? What's that? Annie? No? Sophie? What would go on top? Good. Momentum on top, mass and velocity on bottom. Good. So that would be the circle formula to calculate momentum. Okay. So if I had 2 sledgehammers, for instance, and they were hitting each other, 2 hammers, number 1 and sledgehammer number 2. The mass of the first one, the mass of this first one is 3 kilograms. The velocity of this one is 1.5 meters per second. That smaller sledgehammer hits a large sledgehammer. The large sledgehammer weighs 4 kilograms, 4.0 kilograms, and it's traveling with a velocity of 0.9 meters per second. So the question is, what is the overall momentum of this situation where 2 hammers are hitting each other? Here's hammer 1. Here's hammer 2. It's a little bigger. And they're impacting each other. Hammer wars. Well, the way to figure this out is by realizing that momentum is equal to mass times velocity. So I can figure this out by saying 3.0 kilograms times 1.5 meters per second for that one, and for this one, 4.0 kilograms times 0.9 meters per second. Well, if I calculated this out, this smaller one would end up at 4.5 kilograms meters per second. Remember from yesterday that the unit of force is kilograms meters per second. The bigger sledgehammer, if I multiply these out, turns out to be 3.6 kilograms meters per second. So in actuality, the smaller sledgehammer, because it has more force behind it, is going to exert a larger force on the bigger hammer. And the overall motion is going to go in this direction, towards the direction of the small hammer. Okay. The big hammer exerts an equal and opposite force in the opposite direction. How would we calculate the net force of this situation? Sam?
Well,
Okay.
it
There-
would be a negative number.
Okay. So, realizing that the overall force can't be negative, we're going to take the bigger one and subtract the smaller one to figure out the difference. 4.5 minus 3.6. Borrow 1, yeah, 15, there's 0.9. So it's 0.9 kilograms meters per second. 0.9 meters per second in this direction. So almost 1 kilogram meters per second, 1 newton. We can round it off to 1 newton in this direction of force. Okay? Does that make sense? All right. So that's section 4 of chapter 10. Let's get into the lab for today.